Okay, hi everyone. Today we are going to talk about indexes. So indexes are used to speed up the data access. If a table does not have any index, it does a full scan. So you can think of indexes as shelves basically. Now these shelves, you can arrange the data in each of the individual shelves. So let's say for shelf 1, you would want to keep data 1 to 10. For shelf 2, you would want to keep data from 11 to 20 and so on. Now it is not always that you put index and the speed will be fast. It is only sometimes that it does so. And it is very important to highlight sometimes here. Uh, okay, so there could be two cases. One is you have appropriate number of indexes in which it will increase or reduce the latency. And the second is if you have many indexes, then it could increase the speed as well. So the latency could increase. It is because database must update the indexes. And in case of many indexes, it would be a problem. So basically indexes are used which are queried frequently and the return is smaller number of rows. So in these cases, we would want to use indexes. Now there are multiple types of indexes. One could be a composite index. The second one could be a simple index. Now, in case of composite index, what happens is, let's say you put a composite index on C1, C2, C3. Here the order is very important. So if you query C1, C2, you could fetch from the index. If you query C1, you can fetch from the index. If you query C1, C2, C3, you can fetch from the index. But if you query C2 only, you cannot fetch from the index. Or if you query C2, C1, then it will reorder and fetch. But ideally, if you just query C2, you will not be able to fetch. So the ordering in which you put this is very important. This has to be most common index on which you would want to query. So if you just query C2, it will not hit. If you just query C3, it will not hit. Okay. And in simple indexes, you just put indexes on one particular column. Okay. Now there could be other indexes, other types also. It could be a unique index that you would want to have or a non-unique index. Now, in case of unique index, what in this case there is duplicate name or duplicate key. In this case, there are no duplicate keys. So generally, this is primary key candidate. Okay. Now these also could be divided into multiple types. Basically, you could have a btree index. This is the most common actually. You could have bitmap index and bitmap join. You could have function-based index. And then you could have application domain index. So basically, this is the most common. This is used for primary key and in which you would want to fetch single row. Okay. Then comes the bitmap. In this is used for low cardinality. Whenever there is a low cardinality, like gender is a low cardinality. It could be male, female, or job title is a low cardinality. So in those cases, bitmap is used, and then bitmap join is used in cases where we would want to fetch from multiple tables. So let's say there is table 1, table 2. We would want to fetch from, do a join and then fetch. We have something called as job title here. So we can create an index on job title where table 1.id equals to table 2.id. Okay. Function indexes are nothing but if you would want to apply functions like upper to column 1, column 2, in those cases you would want to use function-based indexes. Here the value is pre-computed. So whenever you do a update or insert, it creates a key in the indexes which can then be used so that it is not called again and again. It is generally used where we would want to have a where clause and we would want to say that upper name is this. Okay, and these are basically custom indexes supplied by user. Okay, so basically most common index is a btree index. So it generally stores the data like this in which you could have, let's say, balance tree. So this would be something similar to a balance tree. You could have records from 0 to 40, 41 to 80, 81 to 120, And then this internally could have multiple balance trees. For example, this, and then you these will be the branch nodes. So these are branch nodes. Here you can segregate 0 to 14 to 0 to 10, 11 to 19. And then finally you have the leaves node in which you store the data. So let's say you would want to store for 0 row 1, for 1 row 2. So in this case, whenever we fetch from the tree, there are an IO operation that we need to do because the height of the tree is n. Let's say these are branches, and in the end you will see these are leaves. Okay, and then we need to do n IO operations to fetch it. Okay, I think that's it for today. Thank you.